Chapter 6 will discuss chemical reactions and quantities. In this chapter, we will discuss equations for chemical reactions, type of reactions. We will talk about the mole, molar mass. We'll discuss about mole in chemical reactions, some calculations, percent yield and limited reactant, and the last part will be energy changes. So the first part is about equations in a chemical reaction. What is the first thing we need to determine? When do we have a chemical change? We have a chemical change when a substance is converted from something to something else that has different properties. When do we observe a chemical change? When we see a change in color, when we see the formation of a precipitate or also a solid, or when we see the formation of bubbles. There are change in color, formation of gas, formation of a solid, or heat can also be produced, and those are examples of chemical reactions. Let's identify a visible evidence of a chemical reaction in each of the following. Methane gas is an outdoor heater. In an outdoor heater burns with a blue flame, so heat and flame will be the chemical changes. Bleach removes stain from a shirt, and then removes stain, changing color. Bubbles of CO2 are released when baking soda is mixed with vinegar, so the formation of a gas. A chemical reaction involves the following: a rearrangement of the atoms, produce new substances, and can be observed by different physical appearance of the substances. How do we describe a chemical reaction? We do it using a chemical equation. A chemical equation tells us what substance react to the left of the arrow and what substance are formed to the right of the arrow. We use plus when we have more than one reactant. This triangle here means heat. Parentheses SLG or AQ, that means the physical state. S for solid, L for liquid, G for gas, and AQ for aqueous. So in a chemical equation, we could say CH4 gas reacts with oxygen gas to form CO2 gas plus H2O gas. So in a chemical equation needs to be balanced. So the first part will be to balance the atoms that are in a chemical reaction. So for example, here we have 2 molecules of hydrogen with 1 molecule of water to form with 1 molecule of oxygen to form 2 molecules of water. We need to count for the number of atoms in each one. So this coefficient here times this one is 4. So we have 1, 2, 3, 4 atoms of hydrogen on this side. On this side, we should have same number of atoms of hydrogen. So we have 2 times 2, 4. Therefore, we have 4. Oxygen, we have 1 and 2. And in here, we have 1, 2, 3. And in here we have 1 and 2, so 2 oxygens, 2 and 2. The equation is balanced. In order for us to balance a chemical equation, what we need is to have these coefficients here. Please notice that the coefficients here, the subscript, are never changed. We never change those, because if we do, we are changing the compound that we have. What we change is the coefficients in the front of the substances. So we count the number of atoms and then we balance, changing the coefficients individually in order to have the equation balanced. So the guideline for this is write the equation, count the atoms of each element, use coefficients to balance them, and then check that everything is balanced. Alright, so let's do this one. We make a list: carbon, hydrogen, and oxygen, carbon, hydrogen, and oxygen. Here we have 2, hydrogen we have 6, oxygen we have 1 plus 2, 3. Here we have 1 carbon, 2 hydrogens, and 3 oxygens. So if we see, only the oxygens are balanced. So we need to start balancing the equation. So for that, first thing we do is we can pick whatever atom we want to balance. In this case, I would like to start balancing with the carbon. So in order for these to match, I can put a 2 here, and then I will have, instead of a 1, I will have 2 carbons. And now my carbons are balanced. Putting these 2 here change the number of oxygens, because now I have 2 times 2, 4, plus 1, 5. And now, even though I have the carbons balanced, I don't have the hydrogens nor the oxygens balanced. So what I do now, I see that I have 6 hydrogens here, so I can put a 3 here. And that changes 3 times 2, 6. So now my hydrogens are balanced, the oxygens are not. Because in this side, I still have 3. And in this side, I have 3 times 1, 3, plus 2 times 2, 4. So 3 plus 4 equals to 7. So in order for us to balance the equation, if I put a 3 here, now 3 times 2 is 6, plus 1, 7, and the oxygens are now balanced. Then let's determine if each one of these equations is balanced. Number 1, we have 1 sodium, 3 sodium. It's not balanced. In order for the equation to be balanced, we need to put a 6 here and a 2 here. Number 2, 2 carbons, 2 carbons. 4 plus 2, 6. 5 plus 1, 6. Oxygen 1. The equation is balanced. Let's check the balance of atoms in the following equation. Number of hydrogen atoms in the products. 4 times 2, 8. Number of oxygen in the reactants, 4. Number of ions in the reactants, 3. Alright, so the last problem in this video will be to balance the following equations. So let's take a look of this. We have 2 irons, no irons here. So we can put a 2 here. And now the number of ions is balanced. Let's take a look of the oxygen. We have 3 and 2. The best way when you have something like that is put a 2 here and a 3 here. So now the oxygens are balanced. You see 3 times 2, 6. 3 times 2, 6. That changes the number of ions. And now here we have 4, so we put 4 here. The last is 3 carbons, 3 carbons. So 2, 3, 4, 3. The answer is B. Let's do the next one. We are going to leave aluminum and iron for last because they are by themselves, so they will be easier to balance. So we see here we have 3 oxygens, so if we put a 3 here, now the oxygens are balanced. 3 oxygens on each. That means 3 irons here and then 2 aluminums here. So the answer is 2, 3, 3, 1. A. In this one that we have here, in the last one, we see sulfate. So I would like to introduce this concept. Sulfate, we're going to balance it as a whole. How many sulfates do we have here? 1, and here we have 3. So if we put a 3 here, we'll have the same number of sulfates in both. In that way, we don't have to worry about oxygen, sulfur, or anything. We just balance the sulfates by itself. Now we have 2 aluminums here, so we write 2 here. And the last part is the hydrogens. We have 3 times 2, 6, so we put a 3 here to balance. So the answer is 2, 3, 1, 3. 2, 3, 1, 3. The answer is B.